Hey guys, Mr. Betts here. I want to look at a few examples where we are considering rates of growth of functions as n approaches infinity. So essentially what we're looking at is, does this limit for each of these, the limit as n approaches infinity, does it exist? And if it does exist, let's also figure out what it is. If it doesn't exist, then we say that the limit diverges. So on the first one, remember relative rates of growth, factorials are the fastest growing of the function. So we have a fraction here where the denominator is getting really, really big compared to the numerator. And so when we take a number divided by a number that's really, really big relative to that number, we're going to get a number that's approaching zero. So this is going to converge. And more specifically, when the denominator dominates the numerator like this, it's going to converge to zero. The second one here, what we have happening is we have an exponential divided by an exponential. So the key to doing this one is rewriting it as e over 3 to the nth power. And so this right here, what we're looking for is if that number is between -1 and +1, when we raise a number that's less than 1 to a really big power, we're going to get 0. And it turns out that e, which is about 2.7, is smaller than 3. So a number smaller than 3 divided by 3 is less than 1. And so a number less than 1 to a really big power is going to go to 0. You can kind of experiment with this on a calculator if you want. Just type in that number times itself and keep hitting equals and see that number get closer and closer to 0. With our C series, we have a factorial, but this time it's in the numerator. So the numerator is going to be growing really fast relative to the polynomial in the denominator. So in this example, the numerator is growing really fast, and this is going to diverge. The third one's kind of interesting. So the sine function is not one of the 4 categories of functions that we talked about with relative rates of growth. But what we know with the sine function is that it's always going to be between -1 and +1. So as the denominator grows to infinity, as n gets really big, 2n also gets really big, we're getting a denominator that's really big and a numerator that is confined to that range. So since that's happening, what we're going to get is some finite number on top divided by some really big number on the bottom, and this is going to converge, specifically converge to 0. I hope you're noticing the pattern here. When the denominator dominates the numerator, it converges to 0. The last example is the same thing, but just the reciprocal. So what's happening here is the numerator is going to infinity. The denominator is bounded by that same range as the numerator in the last problem, so between -1 and 1. And what's happening here is we're getting a really big number on top divided by a number on the bottom that's oscillating, but oscillating between -1 and 1. So again, since that's confined, that's restricted to that range, and the numerator is growing really big, we're going to get really big positive numbers sometimes, we're going to get really big negative numbers sometimes, we're going to get just finite numbers sometimes. But the key here is that it's not approaching some particular value. So this is going to diverge. And we wouldn't even say that it diverges or does not exist because it goes to infinity or negative infinity. It's actually swinging wildly between the two as n approaches infinity.